Okay, so we're gonna wait this 3 minutes and then we're gonna start with the class. So good to see you again here. We're gonna continue with this class. I was saying we have just like, well, today and tomorrow, right, to conclude the topics and the competences that I hope you start like feeling you have with you. And that's the idea, right? At the end of one class, if you feel that you didn't like get any new competence or something, so then I think that you will need to repeat it. No, that's not true, but I think that you will need to explore a little bit more the content on it. Honestly, the class will be better in the other way. I mean, not this way, because the class is like 4 hours. Today, for example, tomorrow is like 8 hours. So we're gonna have enough time, I think, so this way. But we couldn't do it, so this is the chance that we have right now. And I think that I have to summarize some of the content. I think that you see it because we couldn't explore like very deeply, like the successions, like the topics that I proposed to you. But I'm giving you a general, a holistic point of view of all the mathematics that you must know as a teacher in this first and second cycle that you're working on. Okay, probably some of you work in the third cycle. That's so good. That's so good too. But you must know this mathematics. Okay. So I don't know if someone's working right now in the third cycle. I mean, with 7, 8, 9 graders. Nobody? Well, then you have a very interesting responsibility with these children, right? I think it's a very good chance, this class.
Buenas tardes.
Buenas tardes. To explore those math contents, as I'm saying, okay? So, gonna wait just the last minute and then we will start. I'm checking here. Many of the classmates start connecting, so good.
Good afternoon.
Good afternoon.
Good afternoon.
Good afternoon, everyone.
So good. So like I was saying, so good that we finally reached this day, right? I mean, have been I don't know if you feel it like longer or I mean the time of the class, but have been a little bit long, I think so. So remember that we have some important evaluation for this weekend, for Sunday, the project, and I hope that you start working on the report of this one. You have the elements over there in the platform, so you can check it. You should check it. And then the other evaluation we have been getting used to do, like the quiz, the assessment, which is a teamwork, and the forum, which always is individual. Okay. So we stay with this one, the last class, if you remember. And the main idea here is that we start talking about those algebraic expressions. Is it the only way we have to solve some of these situations? Well, not always. There are some new mathematics, I mean, not new mathematics, new techniques to teach mathematics where they don't focus in variables and equations and numbers. They focus just in shapes. You know, if you ever hear about the Singapore method, for example, that's more something of other class that is didactics, I know, but it's something that I have to mention here because it's part two, it's part of what the mathematics that we do in the university are interest, okay? Or it's part of the bunch of knowledge that you must acquire, I think. Okay. So I'm checking that some people is like using other name just to be sure. Who is first B team? Maybe help me with your name, please. Then I write your name for you. Who's the ¿Quién es el compañero que tiene el nombre de First B Team? Si me ayuda, por favor.
Sí, soy yo, Lourdes Vanessa Díaz.
Ok, Lourdes.
Ya me cambió el nombre.
Ah, ok, usted puede, perfecto. Si usted puede, perfecto. Sí, solo para estar seguros, no tengamos ahí problemas o algo ahí. Okay, so we stayed this one, and if you remember, I told you that the math we study in a holistic way is separate into arithmetic, algebra, and geometry. I was expecting to start today with geometry, but we have to conclude many things about algebra, and I think we have those hours today to do it. So we stay with this one, and normally in math, that's like one advantage of mathematics out of other science. Math, it can explore main ideas or ideas inside the same mathematics. Don't know if you ever seen a math proof before or seen a little demonstration of something, because probably you're gonna explore something like this in the bottom of this group. As an example, this is a little math proof working just with algebraic principle. Is the addition of an even number and an odd number another odd number? That's true. I just want to tell you something or ask you something. Are you agree with me if I write 4 like 2 times 2? Yes? No? Because here we
Yes,
have a
that's right.
situation.
Yes, 2 times 2, 4.
Excellent. So if you're clear with this idea, we can apply this idea over here. Of course, this probably will not like be clear at all right now because you don't know why I'm saying this or what is going to be useful. Okay, check it out. If we want to add those expressions, first of all, we should free those from the parentheses, working then just the 2n plus. Well, here this positive sign doesn't affect the parentheses. I think it's something you explore in the last assessment related with the syntactic division, where you add or where you subtract polynomials. Of course, I'm gonna review these because I think to understand the syntactic division or the long division, you must remember how to operate those. I mean, this is a topic of the school, it's true, but it's something that we have to keep in mind at the moment to teach what we will teach. I mean, we will not teach this, it's true, but we want to see the consequence of what we teach. I mean, if students are not clear, like what means add 2 apples and 2 apples, they will not be clear with this. So at the end here, 2 plus 2, and working with the n, because cannot work with the 1, will make 4n plus 1. The main idea is if you can rewrite this expression as 2 times something plus 1 to leave it as the odd number form, sorry, then you can say that the addition of an even number and an odd number, not knowing which one. And I'm here talking about all of them. Who tells you this? Okay, we already tried the succession where we discovered that a rule can describe a bunch of numbers. The same happening here. This is like the succession of the even numbers. This is the succession of the odd numbers. So at the end, adding those, we get something new. And essentially, I can try something with this for n. And it's rewrite it like 2 times 2n plus 1. Looking for the way to have as much as we can, 2 times something plus 1. And yes, it's true. So that's going to be the way. Essentially, I use this principle right now, or this simple idea that 4 is the same as 2 times 2, as you can see here. To make what? To make what? A rule. A rule that starts as an idea or that starts like an idea and then becomes with an algebraic expression into something that's gonna be true for every natural number, I think, because those works in the context of natural numbers, like the successions we were studying. Okay, so I think here with this idea, we couldn't conclude the last class, we can close the part of the algebraic expression. And now can focus on the next part. Now, some algebraic expressions receive a special name. Don't know if you know what are those, or if you ever hear about the polynomials, because this is what we want to talk about right now. Have you ever heard about the polynomials before? Yes, have you ever used it in other situations maybe? Or no idea about the polynomial?
No,
It's
miss.
like an exercise with multiple numbers,
Okay. So if I
like
show you,
binomial by two numbers, for example. Monomial by one number, and poly means like 3 or 4, 4 or 5
okay,
maybe.
okay, but you're using vocabulary here, and that's so good. You're talking about monomials, you're talking about binomials. So you are familiar with this one. You have an idea. Okay, let's talk about the polynomials. It's true, and I think we need to start with there, like you say, with the basic polynomial that exists. We will see what is that one. So essentially, when we talk about polynomials, are algebraic expressions. First of all, they follow next condition. Just work with natural or whole number exponents, okay? And those algebraic expressions are separated by addition, are separated by subtraction. And this is what gives you the amount of terms one of these variable expression has. At the end, polynomials are variable expressions, right? So the main world of all these polynomials is called variable expressions, but a little part of this world is called polynomials, the ones that follow these simple ideas. Working, okay, the variables, right? Variables working with a natural exponent. So the most basic polynomial we can build is like the most basic algebraic expression we can build, just that we have to follow these conditions of working exponents with, sorry, working variables with and natural exponents, I think so. So give me a second. Some of the classmates are like trying to join right now. And we can continue now. So a monomial is like the basic way to understand a polynomial. If you don't understand monomials, then understand polynomials is gonna be a headache, I think so. So let's focus on the monomial first. A monomial is an algebraic expression with the next characteristics. What are those characteristics? Okay, a monomial contains numbers, variables, and exponents. Normally, the number that's over there is called coefficient. Or sorry, coefficient, the pronunciation. The coefficient tells you like the amount of times this expression is repeated. It's something that we already talked in the last time we talked about algebraic expression. It becomes interesting because here you can mix 1, 2, as many variables you want, but do not think that because you have 7 variables with the number 3, then this becomes a polynomial. This is a wrong idea. Many people get confused. It's a monomial because practically it's just working one term. So, and it's one term because the other part should be separated by addition and subtraction. Well, or subtraction, I think is the best way to say it. Okay, the main observation here is that the exponents that we work in here always will be positive numbers. As you can see here, we have the 1, the 2. So each variable normally contains an exponent. And then we will see, so curious, that sometimes the numbers can work with variable expression with exponent 0. So keep in mind that idea. So a monomial is like the simplest form we have to understand a polynomial. So if we are clear with what is monomial, then I think we can go with the part of talking about what happens if we have now more than one monomial, which is essentially something that I think or probably will happen in the polynomials, okay? So depending the amount of terms one polynomial will have, and those terms essentially are monomials, okay? You will create a polynomial. And depending this, you're gonna have like what Lixi was saying. You're gonna have probably a binomial, you're gonna have probably a trinomial, you're gonna have probably a tetranomial, or a pentanomial, or a hexanomial. Okay, it will be so good for us to say that from 4 terms to more, we can call that ones like polynomials. Of course, you should know that they receive a specific name, right? like the hexagon, like the pentagon, all these shapes receives like a specific name, especially because of the number of the sides. Okay, here we're not working with size. We are working with terms, with monomials. Depending the amount of monomials you have in one variable expression like this one, it will receive a specific name. Okay, so I think those are like basic ideas we have to keep in mind to talk about the polynomials. So I want that you identify what's the name of each polynomial we have over there. At the end, yeah, all they are called like polynomials, but they receive a specific name. For example, this one, 2x to the power of 3 minus 5x to the second plus 4x minus 10. What will be the name of this one? I mean, just tell me how many terms does it have? How many?
Polynomial of 4
Is it
terms.
Binomial?
Okay, it's a binomial, it's a trinomial,
The first polynomial, mister.
polynomial. Okay, how many terms does it have?
4.
4.
Four. If this one
Four
has
terms.
4, if this one has 4, to be honest, like the specific name is tetranomial. Okay, but we say it here, we specify that over here, that if it have 4 terms or more, okay, is called polynomial. But to specify the name, it's tetranomial. I think you know what means tetra, and it's related with like the amount of terms it has. What about this one? How this one's called?
Binomial.
Binomial.
Yes, binomial.
Binomial.
Excellent. And what about the last one?
Trinomial.
Trinomial.
Trinomial or trinomial. So I think we are clear with this simple idea. And if we're clear with this simple idea, just let me tell you that this is not just the only way to name a polynomial. It can be named by other simple reason or other simple property. So let's see what's this other property. When we talk about polynomials, we must focus in on a specific value, especially because this one will tell us like which polynomial is greater than another or stronger than another. Okay, if we want to see like the strength of those. One element that we have to focus on is the degree. The degree is the greatest exponent that you can see in the variables. Okay, and according to that degree, the polynomial can receive a name. So you have two ways to name a polynomial, and at the end you can mix those to give the polynomial like a name and a last name. Okay, and normally the name is given by the amount of terms. Okay, or it can be given by the degree too, no problem. But at the end, you have to mix like those ideas in one expression. I think you're gonna have exercise like this in the quiz of this Sunday. So what are those elements? Starting with the degree, easy. Is the greatest exponent that you can see if your polynomial is working one variable. What happens if your polynomial is working more than one variable? Okay, then you have to add those exponents. It's not that you're gonna multiply the variables, no. Because at the end, add the exponents related with this idea, but it's not gonna be like this. So degree is pretty easy. We will see one example then. Leading term. The leading term is the monomial that contains the degree. And practically, if you have like 5x to the second power, and then 5x to the second power, because the x has the second power, makes this term be the leading term, okay? Be the leader. And normally this is so important because at the moment we organize the polynomials, it's not that we're gonna work those in the order of the first number of the coefficient. No, it's gonna be ordered by the degree. That's so important too. Then we can talk about the leading coefficient. I think that if you understand like the leading term is the one that contains the degree, at the end, the leading coefficient is the number that goes with this leading term, right? The number, the coefficient is very simple. And finally, the independent term. This is something important too. The independent term is the expression which normally doesn't have any variable. Okay, and it's called independent because at the end, those variables will get a value. And this value will affect each of the expressions, each of the monomials, excepting for that monomial that is called the independent one. So we're gonna see what is that thing. So here we go. Let's see, and depending the degree now, look, depending that degree, one polynomial will receive a name or another. So here you have like the complement of the other table. Of course, we start with like the amount of terms, but now we have the degree. Degree 0, what happened when an expression has degree 0? How do you think will be an expression with degree 0? How do you think will be an expression like this one with degree 0? Any idea?
An expression with no variable.
So it will be just like a number, right?
Because if you
Hmm.
have, for example, 2x,
It would
but
be
the
one.
exponent, you do not see it, but it's always 1.
Uh-huh.
But you only, I know, for example, 2x plus 1 or plus 2, that 2 has no any degree because it has no variable.
Okay, it has a variable, just that we don't see it. Someone says 1. What do you mean when you say 1? Because I want to understand this point. I mean 5. We don't see it, but it has a variable with this one. Someone who was the one, the classmate who said 1? I couldn't see. Sorry,
It was me.
Vanessa. Okay,
I don't know
you
why,
say
but I
1?
just remember.
Uh-huh.
Oh, well, actually, it's because I just remember from high school, when the variable is 0, it's just 1.
Okay, you got it. But it's not the variable being 0. It's the exponent of the variable, the one that
The-
becomes
Oh,
0.
oh, yeah.
Okay, so then if you have, for example, 5, it's exactly the same as you have 5x to the power of 0. But what happened with expressions to the power of 0? Okay, that's another rule. It becomes 1, excepting for 0. 0 to the power of 0 is not 1. So then 5 times 1, of course, is just 5. So it's not that it doesn't have a variable. No, it has it, just that we don't see it. Because normally is 1, okay? So there he is, and essentially it exists at degree 0, as you can see. And it exists just with constants, which at the end are just like numbers, okay? What numbers? Well, the numbers. And I told you, every time we talk about numbers, we talk about the real numbers. So then what happens if the polynomial has degree 1? Well, that's called linear. If it has degree 2, so it's called quadratic. If it has degree 3, so it's called cubic. If it has degree 4, so it's called quartic, quintic, and so on. Okay? The main idea here is that normally we work until those. Honestly, in high school, we study a lot of quadratic equations. Probably, yeah, a little bit of the cubic, a little bit of the quartic in 10th and 11th, but I think that we stayed with this one. Why? Because many situations of real life can be modeled with quadratic equations. And something else. At the end, the quadratic, the cubic, works with the idea of being summarized in a quadratic equation. Okay, we will see how is this at the moment we talk about the topic of equations. Right now we're talking about polynomials. So I want that you tell me the name of next polynomials. We name it last time with the number of terms they have. Sir, I think you have to ask for permission in your job too. The class is important too, okay? Ariel, I mean, the class is important too, not just the job. I mean, then you will not have an idea of the test. Well, the class is recording right now. Let me check. Oh yeah, then you can check the recording. So what will be the name of the first expression over there? I mean, focus into answer first. What is the degree? What is the degree of the expression of the polynomial? Of the first one.
Degree 3.
It's 3, right? That degree is 3. So if that degree is 3, then it is called like
Cubic.
cubic. Excellent. It's called like cubic. Now, if I ask you, if you want to name like, if you want to give like the complete name of this, This is called cubic, and how many terms does it have? 4, right?
4.
So we say that if this one has 4 or more, this can call polynomial. So this one is called cubic polynomial. What about the next one? What is the degree of the next one?
Quartic. Quartic.
Quartic.
Quartic. Excellent, because degree is 4. So we can call this one like quartic. Now, do you remember what was the name when we focus in the amount of terms?
Binomial. Quartic binomial.
It's a quartic binomial. What about the last one? Give me the name of the last one. I think you're clear with this idea.
Quadratic.
Quadratic trinomial.
Excellent. Is the quadratic trinomial. This is one of the most important polynomials that we will study. Because again, like I told here, focusing a lot of things, and many things of real life are described like with the quadratic formula. So here we have it, a little bit of an introduction of polynomials. Always we must be sure about what are those things to then start looking or studying like how they will be operated. So want to ask you to identify here so quickly that degree, the name, which is the leading coefficient and which is the independent term, just to be sure if you're clear with the main idea of this exercise. So what will be the degree of the first one? Let's start over there. What will be the degree?
2.
It's 2. Then we can focus on the name. What will be the name? What will be the name?
Quadratic
Trinomial.
trinomial.
Quadratic.
Okay,
Quadratic
it's
trinomial.
quadratic and excellent. I think you got it. It's called a quadratic.
The independent term is -10.
Está ansioso, Mauricio. That's true. It's true. That's our independent term. Again, who can remind me why it's called independent?
Because it has no variable.
Excellent. And it makes this being independent like
Yes,
the other
because it's
one.
alone.
Okay, so that would be another good way to see it. Look, if you decide to give a specific value of x, this expression will be affected. This other one will be affected too. But the 10, no. The -10 will stay like -10. The other two will depend of the variable x or the value of x, I mean, that you receive, that you decide to give at the moment to evaluate the expression. So here you have it. It's just missing talk about the leading coefficient. Let me ask you about it. So what's the leading coefficient? Coefficients are 2, 5, and -10. I think you explored this one with the syntactic division. So what's the leading coefficient? No idea?
5.
5 and 2.
5 and 2. Okay. Let's go back and see again what is leading coefficient. Here we have it, the third definition. It says leading coefficient is the coefficient of the leading term. Okay, we have to go back to leading term. Leading term is a monomial with the greatest degree. Okay, so I think that if you identify like what's the greatest degree, which is 2, and immediately you identify that the polynomial has degree 2, you can identify so quickly what's the leading coefficient.
2x.
Okay,
2x. Power of 2.
excellent. 2x to the power of 2 is the leading term. Okay, all that's the leading term. So immediately we just have to focus in that coefficient, and this is the leading. Leading is double G, right?
No, only one.
Only one. Is the leading coefficient. Oh, coefficient double C.
Yes, double F.
There he is, double F, sorry. Yes. So here we have it. Now, what is 5x? 5x is just a term. Okay, it's just a term. It doesn't have any special characteristic, the 5x. So we can leave it over there. Let's focus in the other one. Here we have another exercise. Let's start with the degree. What's the degree?
5.
That is the degree 5. Does everybody agree? 5. Why not 3?
It's the biggest one.
Okay,
think so.
excellent, excellent. That's the reason.
Okay.
Not saying that is wrong. I'm just asking you because this is normally what happened with polynomials. Normally they are not in order. Okay. So 5 exponent 5 is the greatest exponent. Immediately we know we're talking about the degree. Now, if we focus in the next one, if this one is degree 5, what will be the name? And I think it's the name given by the degree and then polynomial, because it has like, well, it has 5 terms.
Quintic. It's quintic.
Excellent. Quintic. It's called the quintic polynomial. Okay, there we have it. And well, what else? Leading coefficient. What is the leading coefficient? Focus in where you found the degree. That's why it's so important to start with the degree.
1 could be.
Excellent. We don't see it, but over here, the coefficient is 1. So this is going to be our leading coefficient. There we have it. And it's just missing talk about the independent term that I think you already identified it, and it's
11. Minus
Negative.
11.
Minus 11.
excellent. The negative 11. Here we have it. This is our independent term, sorry. So this is so interesting and so important because at the end, when we study this topic, the vocabulary is like the base. It's like in geometry. If you don't understand the vocabulary, then everything becomes complicated. So here comes with one more idea. I want that you tell me right now. Are those polynomials? If those are polynomials, then tell me the degree, tell me the independent term, the leading coefficient.
Yes, they are.
Yes, they are polynomials. Are you totally agree? You know, the rest of classmates think the same.
It has a coefficient, variable, exponent. So that's why I say they are,
Okay.
but I'm not sure.
Who was thinking they are polynomials? Diana.
Yes,
Okay, but I appreciate that you already gave the answer. What about the other classmates? They are polynomials?
I have a doubt because it has like a negative degree. Could that be possible?
Okay, let's go back. And that's why it's so important to pay attention on detail in here. It says, polynomial are variable expression working with natural or whole number exponents. Natural or whole number exponents. And I think we start this class talking about those natural numbers, those whole numbers, the world of the real numbers, I mean. So check it out again. Are those polynomials? And I'm saying the title, right, that they are not. Reason why they are not polynomials. Okay, let's see why they are not polynomials. Let me explain you very quickly right now why. Just I need to use another color. I'm gonna use red. Okay, this is not natural. This is an integer. Okay? Here's another observation. At the end, those integer exponents, like this one, the negative exponent, to be honest, because then we have positive exponents working as integers too. But the negative exponents are making your expression becomes the variable on the denominator, and this is not possible for polynomials. Here comes another idea. If this one is inside a root, I mean, the variable is inside a root, no matter if it's a square root, no matter if it's a fifth root, at the end, if it's inside a root, it breaks apart the idea of a polynomial that is just working as a natural exponent. Why? Because those roots are rational exponents. So in the world of variable expressions, we have polynomials and non-polynomials. It's like in the world of real numbers, we have rational numbers and we have irrational numbers. And they have to work separately because some rules will not work in here as the ones that will work in polynomials. And of course, we have to make this separation because those at the end will determine the kind of possible situations that you can model with a polynomial. At the end, polynomials want that, to model many situations. So is this idea clear of when something's a polynomial or not? When something's a polynomial, easy. When you have exponents that are working as a natural number. What are the natural numbers? The numbers we use to count. 1, 2, 3. Well, 0, 1, 2, 3, 4, 5, and so on. Is -2 a natural number? No, it's not. Is 2/3 a natural number? No, it's not. So I think that we have to focus on this little detail. I hope that you don't remember. Here's the observation. Whole number or natural numbers for the exponents, right? Don't forget it. Now, every time, that's so curious. Don't know if you ever seen the structure of the math classes before. Every time you study like a kind of number, then once you're clear like where you can represent that one, how can you classify, how can you name it, how can you, okay, everything, then you start going with the operation. And I mean, that's what happened with fraction in 3rd grade, I think so. Students get like the idea of fraction and then they start to making additions, subtractions and everything, right? So it's so interesting. The same idea here. Now that we are clear with when something's polynomial, what are the elements polynomials have? How can we name polynomials? Let's talk about the operations. Honestly, I'm gonna stop more in the part of multiplication. Not gonna stop a lot in the part of division because you already did an investigation about it. You already investigate the long division. You already investigate the syntactic division. Just want to answer with you the questions that are in the homework. I hope that you have the homework with you or next to you to read like what you answered, okay? To participate. Remember, participation counts, still counting, still being evaluated. And I think some people haven't participated in the class, so try to participate. At least it costs 10 points, I think, or 5, don't remember how many. But there are some points about it. So in the world of polynomials, because we know we can create infinite polynomials because exist infinite real numbers and infinite possibilities for the exponents, we can make rules, okay, that help us to describe what happened with this one. And we have 4 basic operations that we can work over here. Okay, so we're gonna see what are like the main elements that we have to focus on at the moment to work this kind of expressions. Okay, so at the moment to work with polynomials, if you're clear like with the main rules or how they work, I mean, and I think we're clear with how they work, it will be very easy to see how can we operate this. Okay, we're gonna see it right now. So focus on this part. Now we can talk about the addition and the subtraction. Yeah, it's true. We normally separate like the addition one way, subtraction another. Honestly, here we will not do that. If you remember how to add real numbers and how to subtract real numbers, you will see at the end that the addition, the subtraction becomes like kind of special case of the addition. It's not first time I say that. I say it like another class, and I remember someone said, yeah, because when you add positive and negative numbers, something happens. Or when you add two negative numbers, something happens. And those are rules of real numbers. And those rules of real numbers works in the polynomial. So principal ideas of addition and subtraction of real numbers will work in here. As I said, if we can add 2 plus 9, then we can add 2x plus 9x. Because the same principle is working over there, just that now we have a variable with the number, okay? O sea, ahorita le estamos agregando, por así decirlo, las manzanas. I'm meaning to the 2. 2x, 9x, the result will be the same. So 2 plus 9 is 11. 2x plus 9x is 11x. Question, is it possible that you operate 2x squared plus 5x?
Yes, it is possible.
Yes,
Yes, it is possible.
So what will be the result then? I saw someone that's not agree. I don't know. I just want to hear like, what will be the result? Those people who say yes.
7x squared.
7x squared.
7x.
Cubic, 7x cubic, the one is
No, because it's an addition thing. You don't
Uh-huh.
have to add you don't have to add the exponents just when you multiply.
Excellent, Diana. You add the exponents when you multiply. Okay, I think Tiffany wants to say something. I think so. I don't know. I feel it.
Yes, yes. You cannot combine them because they have different degrees. That's what I think, but I don't know. It's like when you are trying to combine two different kind of fruits like that.
O sea que quieren hacer tutti frutti aquí, pero no se puede. En la vida real sí se
Como
puede.
combinar manzanas con aguacates. Una es una fruta y una verdura.
Ok, ahí está. Miren qué mejor ejemplo. I can say it like in the context of math, what means the x squared and what means the x. For example, x squared, it's related with an area of a shape. Square units, centimeters square, square kilometers, and everything, right? X is related with like the length of one side. Can you add the area of one shape with the length of one side of one shape? What will be the result? You say then a volume result. Is it possible? That happens when you multiply the area times the height, for example, of a cylinder. If you know the area of the base and you multiply this by the height, what you create? The volume. But when you multiply it, right? Not when you add it. Because it's impossible to add. And that's why those expressions stays like this. This is like the main reason of why polynomials exist. Because you cannot combine those. O sea, si pudiéramos combinar todas esas sumas y restas, al final solo existieran monomios. No sé si me entendieron el punto. Porque si ustedes ya crearon una regla que eso me va a dar 7x a la 3 por medio de la suma, entonces no existen los polinomios, solo existen los monomios, ¿verdad? So those are unreducible or impossible to operate expressions. It is impossible, right? And that's why here I compared the area with the length, because at the end, this is what we have represent in real situations, right? So let's go a little bit closer now with the idea of the addition and subtraction. And at the end, what matter at the moment to make addition and subtraction, more than solve the simple addition or the simple subtraction that right now I think we have this tool to add and subtract. So sad children are like using this, losing the idea of the procedures in early years. No sé si lo han visto ustedes con los que están trabajando ahorita y de repente están en tercer grado y quieren que los niños hagan una suma. Espérenme, profe, ya vengo. Y si uno sabe que andan trayendo una calculadora, no el papel y el lápiz para resolverlo.
Cuando trayendo al papá.
O andan trayendo al papá de paso, ¿verdad? Ahorita tenemos esa desventaja La pregunta es cómo van a estar los niños de aquí al otro año. Vamos a recibir un montón de sorpresas, ¿verdad? Hay que estar preparados nosotros. Okay, so we have to answer here a little question. What are like terms? And I mean, you made the division exercise, and I think you concluded so good. I was checking the assessment, and you did it so good. So what are like terms? Because at the end, you use like terms to solve that division. So what they are? You can Google it, no problem.
I Googled it and it says that are terms whose variable and their exponents, such as, for example, the 2 in x2 are the same. In other words, terms are that like each other.
What do you think about 2x squared and 5x? What do you think now? Is possible to operate them? No, because they are not like terms. Essentially, like I told you, more than the operation you will do, what matters in polynomial addition and subtraction is understand what like terms are. Are variable expressions with the same variable, that this variable have the same exponent. If it's not like that, then you can't operate those, okay? Because they are different kinds of freaks, like Tiffany said. So, main idea, like terms on and unlike terms. You have here an example, 2x, 19x, those are working same variable. The same for the rest. If you see 32a squared plus 9a squared, check this example, 14.2r, negative 12r, those are like terms. No matter, the coefficient could be a real number, it could be decimal, could be integer, no problem. But the exponent is the one that have to be a natural number. What happened in the other side? Okay, in the other side, you have probably the same variable, but different exponents. Or the most common thing that happens, different variables. Or one expression with variable, one expression that doesn't have variable. So you cannot combine those. When I say combine, I'm talking about the addition and the subtraction. So there are some principles of addition and subtraction that work here in polynomials, and those come from the addition and subtraction of real numbers. How can you operate this? How can you solve this operation, for example? Or I don't know if someone can tell me like what's the solution. And look that I choose the tricky one, that's subtraction. Don't know if someone already have the answer. Okay, two ways to solve it. Honestly, gonna focus more in one, just gonna explain you the other one very quickly. As we normally do operations, for example, if I ask you to add 52 plus 22, then you operate the tens with tens and the ones with ones. The result 74, right? So we can use the same idea here, just that here I'm not working tens with tens. I mean, I don't have tens and ones, but I have cubic term with cubic term. I have quadratic term with quadratic term. I have linear term with linear term. Then I have independent term with independent term. So I think that I can mix the ones that working like they are, just that I'm subtracting, okay? So I can write this exercise using something that's called vertical addition. In this case, vertical subtraction is the same idea. For me, not the best way, but well, I have to give you options. Comparing this idea we try over here You can try the same over there. Working the same variable expressions, I mean the like terms variable expressions below like terms variable expressions, and then make the subtractions of this one. To make this easier, you can do something with that negative sign. Do you know what this negative sign will do or not? Because this is like the hard case.
It's going to change the sign of all of them inside the parentheses.
Excellent. So instead of work with positive m to the power of 3, we're gonna work with negative m to the power of 3. And instead of work negative 4m, okay, we're gonna work positive 4m to the second power. And instead of work positive 2m, you're gonna work negative 2m. And instead of work negative 1, you're gonna work positive 1. And at the end, what you will do is like smash them in an addition. Normally, this is called like vertical addition, because for subtraction doesn't work. So let's call it like vertical addition, like it is. It's true, we're solving a subtraction, but at the end, we're gonna add. What a problem. That's why for me, those are together, addition and subtraction. So we can get it over here. Now we can get the result so quickly. It's like 2 minus 1, right? That's gonna be 1 m to the power of 3. You can write the 1, you cannot, no problem. Then here you have 5 and 4. If you see, they are working the same. It's like in here, you're working the ones with the ones, the tens with the tens. So the same idea here, the same principle, just that now you're working with variables. As you can see here, we have the result. What would be the other way? Okay, this is the vertical addition. We can work this in a horizontal way. Working the horizontal subtraction or addition. What do you require over there? Simple rules like apply distributive property. For example, what Tiffany says, that if you distribute that negative sign to each of these expressions, by those rules we memorize and I think never learn why. The one of negative times positive is negative, negative times negative is positive, is what we will use. So first variable expression stays like it is. There's nothing outside the parentheses multiplying it, so we can leave it like it is. This negative sign will affect all the parentheses, working them. Negative n to the power of 3, positive 4m squared, negative 2m, and finally positive 1. What we have to do then is focus in the like term and combine them. What are the like terms? Okay, normally I use a technique and it's like underline them in the same way. For example, n to the power of 3 is negative n to the power of 3. Here we have m to the second power with the other m to the second power expression. Here I have negative 4m, here I have negative 2m. And of course, finally, I have here the independent terms. So we're gonna operate the ones that are working the same way. The same answer as you can see. 2 different ways to get the same, no problem. All that you have to do is respect the rules that works in those principles, right? Okay, any question about this one? About the addition?
No.
No, what matter here? What's the thing that matter here at the end? Like terms. Okay, sorry, I'm gonna erase that one. Wanna make a question? Or wanna make a comment? Okay, now I think we are clear. So 2 ways to get the same answer. I prefer the horizontal way, honestly, the one that I normally teach. Just that some books prefer the vertical, just because we teach the students the vertical addition too. Same idea or same principle. Okay, let's go now with next operation. Let's go now with the multiplication. For the multiplication, we're not gonna focus in like term. Well, not at all. Here, what matter, like you were saying, is remember those rules of exponents that we normally use. Like if you multiply 2 exponential expressions with the same base, then you copy the base and add the exponent, which is what you were doing when I asked you to add, right? So, and of course, the other main idea is like the real number properties. So here we have like those rules. This one and the other rules of the signs, which are normally related with a philosophical thing. Okay, this is so philosophical, and it's related more with logic than math, honestly. Why positive times negative thing turns into negative? Okay, hay por ahí hay un dicho, el amigo de mi enemigo es mi enemigo. El enemigo de mi amigo es mi enemigo. El amigo de mi amigo, pues es mi amigo. Y el enemigo de mi enemigo, pues viene siendo mi amigo. Esa idea aquí la resumieron. Esa idea filosófica la resumieron. Yo se las expliqué con esto de este libro de, se me olvidó el nombre, El arte de la guerra, pero bueno, ahí aparece esa idea y ese es el origen de eso. So, I wonder we multiply next polynomial. Look, if we are clear, I didn't do it with the addition. Sorry, I didn't do it with the addition. Like start showing you like the basic case to then see how to add polynomials. I think that if you understand like terms, addition, subtraction of polynomials is done. And I think you got it. But with multiplication, we must start like seeing how to multiply monomials. Because if we are not clear like how to multiply monomials, wow, then it's gonna be complicated to understand how to multiply polynomials. So how can we multiply those simple monomials? And as you can see, they are not like terms. They don't have to be like terms to be operated. I'm not talking about that principle. So hard because we have to like break apart those ideas, study like one thing first, the other one later, and then we will see that in division something similar happened. Okay, so how can we multiply monomials? Idea is pretty easy. Here you're gonna focus and multiply the numbers and then multiply the variables. That's why here you have multiplication properties for real numbers and properties for exponent, because at the end the expression that contains an exponent are the variables. And as you can see, if the variable is the same, now we have to make that observation. Just if the variable is the same as we have in here in this property, okay, the same base. If it's not the same base, well, it's impossible to do this. All you have to do is add the exponent. What happened with the coefficients? Come on, with coefficients, you're gonna apply real numbers rules to multiply those numbers. And at the end, the final answer of this, by the product of the coefficients will be -8, and by the product of the variables, m to the power of 5. Those things together make the result or the product of this monomial times monomial case. I think it's pretty clear, right? You can do it mentally then, no problem, but that's when we multiply, not when we add. Do not get confusion with this. So how can we multiply polynomials? I want that you try the multiplication of these monomials first of all, and then we will see like the result. Try to do it in these last 3 minutes. If someone has the answer of the first one, say it, yeah?
Can you please go back to the last slide so I can see the example?
It's just multiply coefficients with coefficients, applying rule of sign, rule of real numbers, and then multiply variables with variables, applying these exponent rules that if they have like the same base, just add the exponents. Pretty simple. Got it? You got it? Okay, nice. So now I think we can go to this part. And if you have the answer, say it out loud, no problem. So we'll have the answer of the first one.
I have it.
Could you say it, please?
36b cubed.
36b cubed, okay. Okay, I see you got it. 36b to the power of 3. I mean, negative times negative is positive. 12 times 3, 36. B to the second, B to the 1 makes B to the third. Nice, you got it. What about the other one? What happened in B? What happened in B, guys? Sorry, my students. I mean, focus in the product of the numbers. That's
Is
the
it
first
like
part.
15
15.
a g quadratic h?
Uh-huh. And the G,
Quadratic.
quadratic. Stays like second power 2, quadratic. Excellent. So one question to you. What's the degree of the first expression? What's the degree of the first answer? What is it?
3.
Cubic.
3. What is the degree of this one?
2.
2.
Little detail. Little detail. No, it's not 2, it's 5. Let's go back. Why is 5? Hay detallitos que se nos olvidan. Miren, ese
Because
es
it's the greatest one. It's the greatest.
uh-huh, but we don't have like polynomial
But we
over
don't
there.
have 5 on an exponent.
Yeah, we don't have a 5 as an exponent, but let's check what is the degree. Let's review it. It's so important, these. So who can tell me, who can read what's degree? It's over there. I don't know if you have like the gray screen. Who can read that what's degree? To remind me, please.
What do you need to read it?
To read degree, yeah.
Degree gives the greatest exponent of the variable or by the sum of the exponents if there is more than one variable.
Okay. So that's why here we have degree 5. It's not that I want to confuse you. It's just that I want that you have clear view of what polynomials are. So here is, that's why it's degree 5, right? Yeah, it's true. There's no 5. There is degree 2. There is degree 2. I mean, exponent 2, exponent 2, and exponent 1. But I mean, I don't have more variables. I just have this one. I don't have more terms. I just have this one. So that degree is the addition of all those because you have more than one variable.
So that means you add them all?
Exactly. When you have more than one variable.
Oh, okay.
So copy that detail, please. What about the next one? What will be the result of next one? Coefficient of the first expression, x to the power 4y. Okay, x to the power 4y, the coefficient is 1. So 1 times 7 is 7. All you have to do is work with the variables, I think so. What will be the result?
Seven x degree 9, y degree 3.
Degree 3 or exponent 3. There you have it. So if I ask you for that degree of this expression, what is it?
So
It's 12. Okay, think about the last one. I think I already take like some minutes of the break. We're gonna have the 10-minute break always. So it's like 6 with 3 minutes. We're gonna come back at 6 with 14 minutes. Remember that when we come back, I'm gonna check the assistance, okay? So we can have this little break right now, no problem. But I want the answer when we come back. So see you in 10 minutes.
nada más.
All right. Vale más que dijo. Okay, so here we have it. The multiplication of polynomials. We want to find next multiplications. And here we go. So what happens if we have now not a monomial? We have a binomial multiplying another binomial, as you can see. So the distributive property now will work twice. And honestly, in some books, they use, I don't know if you ever hear something like FOIL before. No? But in some books, they use this. It's like the idea of PEMDAS. I think that you listen PEMDAS, or you use PEMDAS to teach like the order of operations or not.
Yes.
Yes? I mean, what means PEMDAS? Just to see. Probably someone don't know it.
Parentheses, exponent, multiplication, division, addition, and subtraction.
Excellent. Just be careful here. Those goes together, multiplication and division. Addition and subtraction, they go together too. So parentheses, exponents, multiplication and division, and finally addition and subtraction. This is how you operate. I mean, this is the order of operation. So something similar with FOIL. Don't know if you ever used FOIL before. Like multiplying the first term. Okay? Multiplying the outer terms. Multiplying then the inner terms. And finally, the last terms. So I think that I don't like that way, honestly. I prefer to apply distributive properties like it is, but this is a good idea. I think this comes from the technique of mathematics that's called the ABN, which is practically trying to summarize different ways, focus now in the procedures more than the results. But let's use like the main property that works in here in FOIL. Of course, not having the sign, that sign over there between them, even the X, you know you're multiplying because you're using parentheses. Parentheses gave us like the priority or the idea that this is happening. So check this out. What will you distribute then? You will distribute the 2x with the whole expression, okay? And then you're gonna do the same, but with the -2. The -2 with the whole expression. So that's distributive property over here. Of course, once you do this, you're gonna have like the last exercise, a monomial multiplying a polynomial. So there you have it. You have the 2x multiplying the x plus 4, and you have the -2 multiplying the x plus 4. Of course, now that you are already there, you have to apply this distributive property again, multiplying each of these expressions separately and finding the final answer. So we're gonna multiply that 2x with the x, that 2 with the 4, the -2 with the x, the -2 with the 4. Of course, the idea of FOIL is that you're gonna solve this exercise by one step, and in a quickly way. I mean, it's true. I'm agree with this step, with this way. I mean, in the sense that you solve the exercise very quickly, multiplying the first term, multiplying the outer term. So essentially, you did this part, multiplying then the inner terms, and multiplying then the last term. So you create the FOIL relationship over there. But at the end, it's the distributive property. You distribute each of the elements with all of them. So at the end, you're gonna have monomial times monomial exercises. As you can see here, when I erase those arrows to see it better. And well, now everything becomes like to the first case. That's like the main idea in math. Don't know if you ever seen these like in the addition of fractions. In the addition of fractions, what you do at the end is convert the exercise you have into an exercise where you can add the numerators by the vertical method. Well, the methods we know, the same in here. We convert that multiplication that at the beginning doesn't have like a sense into right now 4 situations that we can work mentally, okay? For example, the first one, 2x to the second power. The second one, 8x. The next one, -2x. And the last one, -8. Now, here's a little observation. We cannot say this is the final answer, especially that we can probably say that this is a polynomial because have 4 terms, or a tetranomial if you want to specify the name.
You can work the middle terms.
Excellent. Those middle terms are like terms, okay? So it's so hard to work with expressions like 5m to the second power plus 3m to the second power minus, let me see, 2m to the second power. Is this a trinomial? Is this a trinomial? What do you think?
Yes, mister.
Okay. And the rest of classmates? One student say yes.
No,
Right now, Diana say no.
I think no.
it,
We can
it has the
combine.
same degree, right? That's why it's-
All they have same degree. So what happened? I think someone wrote in the chat that you see.
We
So
can
Aurora
combine
say
them.
yes. Okay, that's the point. We can combine them. Question is,
Do you
we
have to
combine?
simplify the
You have to.
result?
You have to. You have to. I mean, in polynomials, you want to talk as much simpler as you can. Of course, these three variable expressions, these three monomials right now can be operated. Okay, they are working like they, I mean, they are like terms. So immediately, I mean, it's the same as you have 5 plus 3 minus 2. I mean, at the end, what's the result of this? That's 6, right? That is 6, right? Same in here, 6, but with n to the second power. Now, you're not gonna be saying over there, I need 5 plus 3 minus 2 markers. Or you're not gonna go to the supermarket and ask for, I don't know, 5 plus 3 minus 2 pounds of meat. Don't know if you understand my point. You can simplify, okay, simplify it. That's one simple rule of math that even in the real life works. So, final answer will be, oh, okay, thank you. Yes, you're finding the final answer. Let's focus on the final answer. Final answer of this exercise, true, it will be 2x to the second power plus 6x minus 8. And well, that's gonna be it. That's everything about the multiplication of polynomials. It's pretty easy. As you can see, there are some principles we have to focus on. Always combine if it's possible. If you have like terms, come on, join them. Don't leave it over there like separately. No, you have to join them. Always simplifying the expressions, okay? So finally, we're gonna talk about the division, and then I think we're gonna conclude talking a little bit of the equations, which is like the closure of the part of algebra to finally talk about that geometry, which wanna be like the last class, okay? Remember, so we just have this weekend and then, well, class is over. So polynomial division. What do we know about polynomial division? As we try it in the multiplication, where we have to focus in rules of exponents and rules of multiplication of real numbers, something like that will work in here in the polynomial division. Here we have to focus in divide real numbers and exponent property. So how can we solve that division? Pretty simple, pretty simple. One idea here is that you can rewrite one division of polynomial as a rational algebraic expression, as you can see here. If I ask you, is this a polynomial? That's not a polynomial because you have a variable on the denominator. But this expression right now is telling you that you can make a division or that you will do a division. So this would be another idea, I think. Do not get confused with those. Of course, we're not going to have the time to explore the rational algebraic expression. I mean, like the non-polynomial expression, but I think we're going to have a clear idea of polynomials. That's going to be enough for us. So what will you do? You're going to operate the numbers, the coefficients, as we did it with the multiplication, and then you're going to operate the variables using the rule of exponent in that case. Don't know if you remember what's the rule of exponents over there. Don't remember? There he is. In multiplication, you add the exponent. In division, you subtract the exponent. Pretty simple. So 8 divided by 2, I think you know that's 4. And then x to the power of 5 divided by x to the second power. Instead of add, we're going to subtract. We're going to subtract 5 minus 2, of course. There he is. Final answer, 4x to the third, or just like that, 4x to the third power. 4 times x to the third power, I mean, which at the end is just 4x to the power of 3. There you have it. So this is how the polynomial division works. No, this is the monomial by monomial. The polynomial division, okay, I'm gonna show you just like some examples here. You already investigate about it. And honestly, I'm not gonna evaluate a lot of I mean, I already evaluated that part of the polynomial division, probably something like that on the quiz. But I want that you be sure of something, especially the questions that you answer. Okay, so I will need that someone read the questions when we conclude this topic. So at the end, to divide monomials and monomials, all you have to do is focus in the coefficients and then in the variables. So here you can apply one more property, and this is the case when you have a polynomial divided by a monomial. This is going to be useful to see how the polynomial division, the long one, the long division or the synthetic division works, because here is like one simple idea. For example, if you have an expression like this division, the result of this division can be given by dividing each of the terms of the first polynomial by the divisor, which is 2x to the second power. Why that's possible? Okay, I'm gonna show you here, rewriting this as a fraction. Then you can separate them. And why that happened? Why is it possible? Okay, because of the property that I'm showing you right now. And this is related like when we operate same denominator expressions, all you do is like copy the same denominator and focus in the numerator, right? Adding or subtracting the numerator expression. Yes, it's true. But now we're doing the opposite. We're like breaking apart each of the expressions we have on the top, on the numerator, I mean, and separate these ones by the expression we have in the denominator. Of course, what do you have in here at the end? 3 exercises of division of monomial by monomial, as you can see. So we're gonna divide 2 by 2 and make the subtraction of 4 minus 2. 2 divided by 2 is 1. We don't see it, but there he is. 4 minus 2 is 2. There you have it. What about the next one? Well, the negative sign stays there. 8 divided by 2, come on, that's 4. Then we have 3 minus 2, that's 1. We don't see the 1, the exponent 1 over there, but it's already there. And here comes like the main idea why I told you that when you have a constant number, the variable that goes with this one is the variable to the power of 0. Check this out. 6 divided by 2 is 3. What is the result? Who can tell me? What is the result of x squared divided by x squared? Here is the property. So let's apply the property over there.
Se cancela.
It's like they cancel, they are the same, okay? It will be x to the power of 0. X to the power of 0, we say, is 1, okay? The idea of that they cancel is because those exponents cancel each other. It's true. So at the end, divide the same by the same is 1. That's why when you work like 5 divided by 5, well, the main idea is this is 1, but mathematically, why is 1? Because it's 5 to the power of 0, which is 1. So polynomial division and multiplication, as you can see, especially the multiplication, focusing how to multiply monomial times monomial. Here, for this case, which is the one that I'm gonna evaluate on the test, will be like this. Okay, hope that you're ready with the homework, with the assignment, I mean, because I want that you read like the result or the final questions that you have over there in the investigation you did. Especially that here you have the main polynomial division. Polynomial division require all of the other operations, require that you identify so good the like terms, require that you do as well multiplication, and of course simple divisions like the ones we tried. Okay. And I think you did so good this job. I don't know if you investigate this one so well or if you use the YouTube video I shared you. But at the end, there is a simple advantage between them. One's more like a general than the other one. I don't know. So who can read the questions that I have on the, who can read the questions we have in the assignment? Don't remember those questions?
I think I remember the first one was, is it possible to use long division with the exercise B?
Uh-huh.
In the exercise B, and the other one, if it was possible to solve with
Synthetic division.
The
synthetic
exercise
method.
A.
Yes.
Mhm.
Yes.
So let me tell you that one answer is yes. Another answer is no. Okay, I'm checking. You're writing in the chat. It's impossible to solve division by long division method. Okay, there is the first question. The exercise B. And the exercise A by the synthetic method. If you remember, the exercise A, I asked you to solve it by the long division. The exercise B, I asked you to solve it by the synthetic division. Those are the questions. I think it's better if we open the assignment and show it here. It will be like this, just because I wanted you to be clear of this little detail, especially that, well, as part of the class, be clear with those details of long division and synthetic division. I'm gonna show those very quickly and gonna make the questions and answer the questions very quickly too. Because I think not that you answer it wrong, no, you apply the method, but probably you're not clear with the method. So here it is. I think everybody's watching the assignment, yes? I just did a little review too of the elements of the division too, if you don't remember it, because it's so important in here to talk about the terms. So if you see, I asked you to solve this one by long division. Then I asked you to solve this one by the synthetic division. Is it possible to solve the exercise B with the long division method? Honestly, yes. What do you think about the letter B? Is it possible to? Is it possible to solve the exercise A with the synthetic division? Yes, no. Read what you wrote in the assignment, no problem.
Mister,
Uh-huh.
in our team, we wrote that is the number 2, right? Is it possible to solve division A by synthetic division? Is it that?
Yeah.
Okay, our analyze was no, and we were reading is not possible because synthetic division is a shorthand or a shortcut method of polynomial division in the special case of dividing by a linear factor. And it only works in this case. Synthetic division is generally used, however, not for dividing out factors, but for finding zeros.
Finding zeros. Exactly. The main idea of this method is find the zeros. It's true. And I like that you say the condition. And now that I think we have the vocabulary clear, what happened with the divisor of the division A? What's the name of this expression? What's the name of this polynomial? Can you tell me?
Quadratic.
It's a quadratic. And the main condition to apply the synthetic division is you're going to divide by a linear. What means linear? That degree is 1. Okay? And it's true. This topic, honestly, is more related with the factorization. Here, you can apply something that's called the Ruffini's method to factorize polynomials in a general way, but will not be like the best way. Sometimes we have other ways. And I think we're going to explore a little bit of those with the topic of equations, which now is our next topic. Of course, this part of the long division and the synthetic division, if you get it so well, which at the end, the long division is like the division we try, okay, the division we try with numbers, just that is translated to the word of polynomials. You will see that here in the long division, well, you're going to use all the operations, addition, subtraction, multiplication, even the same division of monomials, okay? But in the synthetic that you have to follow this condition. So no, you cannot divide the exercise 1 because it works.
Peter, can I read my answer?
You're gonna send it in the chat?
No, no, what's the questions?
Okay, please.
Okay, my answer to the question number 2, it is possible to solve division A by the synthetic division method. It cannot be solved in this way because none of the divisors of the independent term, when multiplied by the factors, give us the 0. We need to factor the algebraic expression.
And it's true because at the end, this synthetic division is the remainder 0, which if you remember the synthetic division result, like the last number you have over there is a reminder. If it's 0, so good because you find out a factor. Are factors important? You're going to see that they are important now that we're going to talk about the topic of the equations. So, is there any question about this thing of the division? Or the multiplication of polynomials, the addition, subtraction, something that's still not clear to you? Okay, everything's going good. Now, so now we can focus in the part of the equation. For the part of the equation, I think that I will present now we'll share you other presentation. Give me a second. There it is. And now we can talk about this main topic. Look, this is like the closure of the algebra, and this is the connection now of like all properties we have been talking, because at the end, why we have to learn to operate polynomials? Why we have to learn the properties of real numbers? Why we have to learn study the applications or the connections between the areas for the equation. Equations is like the main topic of mathematics, especially that based on equations is where you create like some rules of real life, okay? Don't know if someone here works I'm gonna say in Spanish. ¿Alguien ha trabajado en el área financiera tal vez de alguna empresa? ¿O conoce más o menos de ese trabajo?
No, not really.
¿No?
Me.
La verdad es que mucho de lo que se utiliza en una empresa, por ejemplo, el lenguaje de las empresas, ¿verdad? Tal vez algunos han escuchado de las ciencias comerciales, el debe y el haber, ¿verdad? Ahí estudió contaduría de repente o es perito. Eso es un dolorcito de cabeza, pero al final son puras matemáticas. Y ese es el lenguaje de los negocios, el lenguaje del debe y el haber. Al final, lo que hemos estudiado, razones, proporciones, directamente proporcional, inversamente proporcional, tienen su uso en esos contextos. Y todo nace a partir de una ecuación. Entonces las ecuaciones vienen siendo una forma de englobar, o mejor dicho, de llevar las matemáticas a suplir una necesidad real. Eso es lo que vamos a ver ahorita. No cómo se suple una necesidad real con una ecuación, pero ustedes ya han visto, por ejemplo, hemos resuelto problemas, ustedes han resuelto problemas, han investigado problemas para el proyecto y se han dado cuenta que detrás de cada una de ellas pues va a haber una ecuación. Creo que alguien quería decir algo, no alcancé a ver quién. No? Okay, so let's start the topic of equations then. So objectives. Always gonna start reading a little bit what we want, what we expect about this topic, about this content. First of all, we want to define a mathematical equation. Yeah, because in other science, like physics, like the same science, or what's the word? Yes, science, require that you focus in different kinds of equations, but we're going to define the mathematical one. Differentiate the algebraic equation with the arithmetic equation. That's so easy. I think you know what's the difference now that you know what algebraic expressions are, and we have been talking about numbers. So apply the equation's properties to solve it. We're gonna see how to solve the equation. Of course, I'm gonna focus in like the basic equation. Probably you remember so good how to solve this one. If not, I think this will be a good review. And finally, the most interesting part is determine the solution of an equation. So let's start with this objective. I'm gonna start telling you like what is an equation. I want that you do it better. So give me like 4 ideas for equation, about equation. Remember that you can annotate here your ideas. There's one option that let you like write text over here, so you can write over here. No problem, write it. Mark and give all those 4 ideas here in all this around it, in all this space around. Four ideas about equation.
Excuse me, sir, about what is equation?
Yeah,
Or-
what is an equation? I mean, what's like the first idea you have your brain when you hear the word equation? The word equation. Number, sentence. Someone wrote in the chat, Vanessa, I think. Could you share it here, Vanessa?
I'm not sure.
So you want a meaning or the meaning, sorry, or an example?
The meaning. The meaning.
meaning.
Your idea about equation. It could be just one word. I mean, yeah, you sent something in the chat. I like it. It's a number sentence. So you can share your other ideas. There's one option that let you like text. Don't know if you can check it. There's one option that let you like introduce text. You have the option of drawing. Then next to this one, it says text. So you can write over there. No, any idea? Okay, say
I
it.
don't have an option here, so.
Oh, there you have it. One idea is numbers and signs like positive, negative, and times. That's so good. What other idea of equation? It will be just like one word if you want. One word. Expressions on both sides of equal same sign. Okay. It was
Para
Rixie.
mí, es que encontré un cable.
Okay, let's see. Equivalent. Okay, interesting word. Equivalent. Mathematical expression. A statement in which two things are equal. Okay, statement in which two things are equal. No matter if you overlap on your class, man. I'm taking like screenshot of everything you write. That's so good. One more idea. Because I like that what you wrote over there. It could be just one word if you want it. Equals. Okay. I'm gonna take the last screenshot, and yeah, we have to continue. Time is running over. So let me clean all the drawings. So good. I think you gave good ideas. I like the word equivalent, expression, and at the end, let's see. So when we talk about this kind of expression, essentially, and I took this one from Khan Academy because like the most exactly, it's an equation. An equation is a statement where two expressions are equal. It's an expression, okay? You can talk about variable expressions, you can talk about numerical expressions, you can talk about of a mix of them. But what they do is that they create equal relationship. Is one of the most important things in real life. Conclude when two things are equal, okay? And yeah, the numbers help us to understand this, because what happens if they are not equal? You cannot say that they are not equal and that's it. No, then you have the other comparative, the other way to compare, greater than, less than, And those are the options. But in this case, we're going to focus in equal expression. So essentially, two mathematical sentences that have the same value, or practically that representation, they are representing the same. I mean, little observation, we can have numerical expressions and we can have algebraic expressions. As you can see, the left side, you have 2 plus 3, it's 5. It's like getting a value. So this is based on numbers, and it's what we normally use. And the other one is working like variables. What happens when you work with variables? Okay, there is a requesting. Here, you are requesting for an answer. In these expressions, you are requesting for an answer, okay, for a specific value. Here, the same. Well, probably not just one, but the main idea is that you don't know what's that value.
You have to
Yeah.
give a value to the coefficient.
Okay, to the variable. You can give a value
Sorry, to the variable.
to the
Sorry.
variable. Yeah, no, it's true. I like that what you say. It's true. You can give a value to the variable, but this value probably will make this work or not. And that's like the main idea. If this one is a statement, it will have a value. True or false. What we have to do is look for the value that make it true. What value is this one? Okay, we will see what's the method to do this. The same in here. I mean, at the end, if I say 2 plus 3, it's equal 7, you will not be agreed. That's not equal. I mean, that's false. And because those are statements, they will get one of those values, the values of true or false. And at the end, when we compare two things, that's what we expect. Get something that is true, get something that is false. And of course, this is based just not in the rules of mathematics. This is based in the rules of life too, or of real situations. I mean, when 2 plus 3 becomes 7, well, probably in the base 10 that we work is not gonna be like that. Probably in other base of numbers, it's gonna be like this. But in the context we work, and when we say numbers, we talk about the real numbers that are based or that are working on the base 10, doesn't work, okay? So that's why it's so important to consider these as a statement. Let's see something else about the equations. Those can be algebraic or numerical and can create a mixture of both, okay? So I hope that you don't forget what's the main idea of statement in this presentation that I make. And don't forget that one equation at the end will get a value of true or false. And what we want is get the value that makes this true. It's like the main idea. So here we have basic properties, and those will be useful to solve equations. I think we're gonna focus a little bit on this next class. In next class, we're gonna conclude very quickly. I think that next class, if you remember the schedule, we start like at 8:30. At 8:30, yes, tomorrow to 9:30, 1 hour. Then a break until 10. And then we have 1 hour and a half to conclude. Probably will not use all the time, okay? Remember that we have the project this weekend too. So what are the basic properties that will help us to solve the equation? The reflexive property, that practically you will have one expression equal to another. Probably they don't look like, but they are the same. This is like the first supposition. I mean, 2 times 6 doesn't look like 10 plus 2, but they are the same. So this is the reflexive property, because at the end, 2 times 6 is 12. 10 plus 2 is 12. So they are the same. So this is like the basic, one of the basic properties. Suppose both things are equal. Of course, in the topic of equation, we want to work, we want to study. We're gonna have like 2x equals 12, for example. And we're gonna look for the value of x, not guessing, using this property. What properties? Okay, here we have another one. Other property is related with the symmetry, and is that this expression, like we have it right now, can be written like 12 equals 2x, and it represents the same. I mean, 12 is the same as 2 times something, or 2 times something is the same as 12. It doesn't affect the equation at the end. So those are like basic properties. And here comes one of the most important properties, the transitive property. And the transitive property, it's a kind of relationship that tells you that every time you have two expressions that are equal, but one of those expressions is equal to the other one, in consequence, the first one will be the same as the other one. As for example, if I have then, and check this out, x plus 10 equals to 17, to say something. This is like the first property. But then I say that 17 is the same to have 7 plus 10. So then immediately I can say that x plus 10 is equal to 7 plus 10. Ah, and what happened over there? Immediately you know what's this. Oh no, because we'll can see it with this one. Okay, so the transitive property is one property that will let us solve equations, because at the end, what we do with one equation is transform this one into a situation where it's easy to see or immediately obvious to see what's the solution. Okay, so those are very simple ideas. Let's conclude this class with this activity I have over there. I just want that you identify what property is which one. Use letter R for the reflexive, use letter S for the symmetric, and use letter T for the transitive to identify these properties. Okay, so what will be the transitive? What will be the transitive? What will be the reflexive, and what will be the symmetric? I think it's pretty easy to see, right? So you can mark or you can tell me. I'm gonna write like letters. This is letter A, letter B, letter C.
Letter A will be transitive.
Excellent.
Letter C is going to be reflexive.
It's the reflexive. And of course, the last one is the symmetric.
Symmetric.
Excellent. Look, these properties will give us like the basis to focus in the properties that will help us to solve equations. What are those properties to solve equations? Well, this one. Those are equations like to keep the balance in one equation. And those are the ones we will like continue studying tomorrow because it's already time. Yes. Just gonna mention this one very quickly. To solve equations, we want to focus into the addition property, which tells you that when you have two expressions that are the same or that represent the same, then you can add something in to any of the two expressions, but you have to add the same to the other expression to keep the equation working. It's like a balance, okay? If in a balance you have like 5 tomatoes over here and 5 potatoes over there, or 3 potatoes over there, if I add like 1 apple over here, I have to add 1 apple in the other side, like to keep the balance. That's like the main idea here, keep the balance. And as you can see, essentially, if you do something in one side of the equation, you have to do exactly the same in the other side of the equation to keep the balance or the same sign, okay? So that's gonna be it for today. It's already 7 o'clock, so we have to close the class, I think. And I'm gonna stay here. Any questions you have, if there is one or not, so you're free to go then. Any questions?
Yes, I just have one question about our project that's on Sunday. How are we supposed to do it? Is that I don't have it that clear. Are we just going to connect with you and the group, or is general, all of the classmates and you included, and we have to make our presentation?
¿De qué me está hablando? ¿De presentar el proyecto?
Yes. I know it's until
Okay.
Sunday, but I'm a little confused.
Ok, bueno, en la reunión que tuvimos el fin de semana anterior, no va a haber una presentación de proyecto como tal, solo me van a enviar el informe, ¿verdad? O sea, por volverse a reunir y todo, no se preocupe, mañana es nuestra última sesión, ¿verdad? O sea, mañana hay que preparar ahí la bolsita de churros, el fresquito, quién va a traer los sándwiches. Bueno, normalmente en las estoy bromeando, pero sí me refiero a que no va a haber una reunión como tal, no va a haber una presentación para que todos los demás compañeros lo vean. Ahora, yo sí voy a hacer algo. Yo voy a subir un documento en el Classroom, un Google, para que ustedes lo puedan descargar y puedan ver el proyecto de todos los demás compañeros, porque al final ahí hay un compendio de recursos que les pueden servir incluso a ustedes, lo que investigaron de los juegos. Traten de enseñar con juegos en matemáticas, traten de hacerlo. O sea, a los niños les gusta, ¿verdad? Tal vez a uno no, a uno que lo pongan ahí, que se pare, que se mueva y todo, es un poquito difícil, pero a los niños les gusta y lo hace atractivo también al mismo tiempo. De hecho, esa es la nueva metodología que se quiere implementar, las matemáticas lúdicas. Pero bueno, en su momento llegará su apogeo. Entonces, Ana, no se preocupe, no va a haber una reunión en la que ustedes tienen que hacer una presentación PowerPoint para evidenciar todo el proceso que hicieron, ¿no? Parte de eso ya lo evalué con la reunión que tuvimos, ¿verdad? Y nada más sería presentar el informe con los aspectos que les mencioné. En un PDF, ¿verdad? Eso sería todo, en un PDF, porque a veces si me lo mandan en Word, se mueven las cosas y causa un desorden y eso genera malos entendidos. ¿Alguna otra duda?
Mister, mañana la reunión comienza a las 8:30 de la mañana o a las
Así
9.
es. No, a las 8:30, como lo habíamos programado desde el inicio. La vez pasada fue a las 9 por un impasse que tuve yo, un impasse personal. Y la vez pasada, pues bueno, ustedes fueron partícipes de la capacitación, ¿verdad? El espacio que hubo de capacitación, que era obligatorio participar. Y bueno, yo espero lo hayan aprovechado ese tiempo también. Bien, ¿alguna otra duda?
Sí, es porque como usted envió una imagen acerca del schedule y dice que el domingo, que es 31, debemos de conectarnos, pero ahorita nos dice que mañana ya es la última clase.
Sí, estoy cambiando eso porque no lo veo necesario que nos conectemos para presentar el proyecto. O sea, si yo lo puedo leer, pues. Es correcto, al inicio yo lo dije, pero creo que el fin de semana, cuando nos reunimos, se los mencioné, que ya no iba a ser necesario, solamente enviar el informe. ¿Verdad? No iba a ser necesario la reunión, yo no lo veo necesario, honestamente. Y más que el domingo, pues. O sea, creo que ustedes están cansados, ya es final de año, bueno, para algunos es inicio de año más bien, pero ya, o sea, ya estamos llegando al final. Como les digo, pues, mejor dejémoslo así y para darle lectura a un proyecto creo que lo puedo hacer yo, ¿verdad? No es necesario que ustedes estén, eso sea un trabajo, bueno, la verdad lo han hecho, un trabajo muy excelente, ¿verdad? La verdad es que en eso sí les digo, estoy satisfecho. Algunos equipos quedaron pendientes tal vez con el planning, espero le hayan puesto ojo a los detallitos que les mencioné y que los hayan considerado, ¿verdad? Porque igual me interesa que tengan su puntaje correcto, ¿verdad? Bien, ¿alguna otra duda?
Bueno, no sé, eso creo que sería mañana. ¿A qué hora se va a activar la última prueba el domingo?
El
Sí, eso iba a
domingo,
preguntar lo mismo, si iba
ok.
a ser todo el día o
No,
solo.
no, recuerden que habíamos quedado que solo era más bien de 10 a 11, ¿verdad? Que se iban a hacer las pruebas. No recuerdo si era de 10 a 11 o de 11 a 12, que solo era una hora. Pero se las voy a dejar activada desde las 8 hasta las 11. Eso sí, una vez que la abre, usted tiene una hora para resolverla, porque la prueba tiene un timer. Y a veces se puede enviar de un solo. O sea, se termina el tiempo y envía la respuesta. Además, las pruebas no son complicadas, pues son máximo 2 ejercicios que ustedes pueden resolver, algunas preguntas de verdadero o falso, de detallitos que hay que tener en cuenta porque no se nos pueden pasar por alto. Entonces, la prueba el domingo va a estar activa desde las 8 de la mañana hasta las 11. Si hay algún impasse por energía o algo, de inmediato, por favor, escríbanme ahí al WhatsApp, ¿verdad? Por favor. Pero de inmediato, o sea, ahí tal vez, si se les va el internet, consíganse una recarguita o algo y me lo comunican. O llaman a algún compañero o compañera y que me avise a mí. Pero sí pido que vayamos concluyendo y de hecho las actividades de esta semana las dejé para el martes porque yo tengo como fecha límite el martes Entonces les voy a pedir el favor de que no me manden el martes a las 12 de la noche la tarea. Ok, si pueden enviarla antes, mucho mejor. Si la pueden dejar ya lista para el lunes, mucho mejor. Para yo así subir sus notas el martes. ¿Verdad? Y ya sepan ustedes cuánto tienen también. Bien, si no hay ninguna duda, pues será hasta mañana, si Dios así lo permite.
See you.
Okay, see you. Good night.
Thank you.
night.
Good night. See you.
Bye bye. See you.
Bye. Thank you.
Bye.
Good night.
Welcome. Good night.